This is lecture 11 of our AP Calculus course. In this video, we're going to cover intermediate value theorem, Rolle's theorem, and the mean value theorem. Let's have a look at intermediate value theorem, right? Intermediate value theorem. Right. So what's the intermediate value theorem? Intermediate value theorem is a good theorem for finding roots in some intervals. That's it, in some intervals. So we can have a look at a question and check if there is a root. So what's the setup of the intermediate value theorem? The setup is obviously you have some function, right? So we have a function, one value hits negative. So if this value is a, right, then this point over here is f of a, okay? And if there's another value on top, which is b, then this point is f of b, right? So a, this point is a and f of a, b and f of b, b and f of b. Now, if I tell you to connect this, remember the function needs to be continuous, right? Continuous function means there must be no breaking point in the function. And since this function is continuous, if I tell you to connect these 2 points, there's so many ways of connecting. Obviously, the shortest path will be a straight line. Just say if the function does this, okay? I just connected those 2 points, right? So now what we see here over here is that we get a C value. We get a C value such that f of C is equal to 0. The value of f of C, what is f of C? 0. Are we good, guys? So what's the setup of the intermediate value theorem? One value must be positive. This is the setup. Let's move this graph to the side. The setup of the intermediate value theorem is number one. One value that you substitute must be positive, and the second value that you substitute must be negative. In other words, one is above the x-axis, one point is below the x-axis. So when you connect the 2 dots using continuous function theory, we have to get a value C. So what we say is they exist. What does the symbol means? The backwards E. The symbol means they exist. What exists? There exists a value C. There exists C. There exists a X is equal to C. Isn't this value is X? All these are X values. There exists a value X is equal to C such that, what does ST mean? Such that, yeah, where is C? There exists a value C in the interval A to B. It has to be in the interval A to B such that f of C is equal to 0. In other words, all you are saying is there is a root between the interval A to B. You are not solving for C explicitly. Are we good? Now, sometimes you have to find the interval yourself, and sometimes they give you the interval. So you just need to show that there is a root in the interval. So I do have some questions, right? So there's one question here. That's basically the intermediate value theorem setup. So do you understand, guys? It's very simple.
So could you
Nothing.
explain this formula that you got S times T times F of C equals 0?
What formula?
This one here. S times T times F of C equals 0.
No. This here means it's not S times T. This is
Uh,
the English word such that.
oh, such that F of C equals 0. Oh.
Yeah, it's not formula. So you can abbreviate such that in math, in AP calculus. You can just call it ST, S dot T. Right, that's what it is. It's not a formula.
Wait,
All
so
right,
Mr.
guys. So
What in this case, sorry, in this case, what is C?
C is a root. but we don't care what root.
of A to
Yeah,
B, right?
yeah.
Of the
So
domain A, B. Okay.
yeah, so I can give you my own example. I want you to estimate square root of 7. Square root of, let's take a difficult one. Square root of, say, square root of 53. Okay? Square root of 53. So we need to set up a function for square root of 53, all right? So we say let x be equal to square root of 53. We're going to square both sides. We can say x squared is equal to 53. I want to make a function, all right? So we're going to say x squared minus 53 is equal to 0. Are we good so far? Now, what we're going to say, let f of x we're making let f of x be equal to x squared minus 53. Right. I'm going to choose two values. I'm going to choose two values such that I'm going to choose two values so that I can get the answer for square root of 53 in between some interval. So I know that 7 squared is 49. So I'll choose f of 7. That's my a value. Okay, f of 7 is 49 minus 53. Guys, just switch off, Mesa, switch off your microphone.
Ah, yes.
Mesa,
My bad, my bad.
yeah. 49 minus 53, we can see that the value is -4, which is less than 0. So what's the conditions for intermediate value theorem? One value negative, one value positive. So we got a negative value already. That's great. And if I substitute f of 8, we are getting 64 minus 53, right? Which is equal to 9, 11, which is greater than 0. So what we can say is that they exist x is equal to c in the interval 7 to 8. We know exactly that the answer can't be 7 and 8, so it must be in between 7 and 8. Now you can put a round bracket because you know where that lies, such that f of c is equal to 0. So what you are saying here is that there is an answer for c which is between 7 and 8. What does this here mean? This means on the number line, it means that, okay, I substituted 7, right? I've got -4 as a y value, negative, right? When I substituted 7, I got -4. And when I substituted 8, I had a positive answer, which is 11. So if I connect these two, I will get a point C. The answer for C is between 7 and 8. That's what I'm saying. So what's the answer? X is equal to C. There exists a root. There exists a root. I forgot what there exists a root x is equal to c. What is c? You didn't define what is c. There exists a root right here. There exists a root x is equal to c. X is equal to c is a root. So all we are saying that the answer for square root of 53 is between 7 and 8. Are we good, guys? You understand? Hello.
Yes, yes, Ghazali, easy.
Wait, mister, so C,
It's a
it's any
root.
number, it's just we don't know what it is.
Yeah,
Or
we don't
it's
want to
a
solve
root,
for
like
it.
you said.
Yeah,
Okay, we were solving for it as well.
intermediate value theorem says do not solve for it. Just give us an interval where the
Okay,
answer is in. That's it.
yeah. That's why we're
We are
not
not.
including the 7 and 8 because it's neither of the two answers. It's
Yeah,
in
yeah.
between that, right?
It's
Okay.
in between that. Yeah, that's correct.
It's in between that. Okay.
That's great. So I just gave you my own example. Obviously, I have more examples for you to solve. I'll just do 2 examples on each. All right. The rest of them just will give you as homework. I have some examples prepared here. Uh, I just crop it. So that was 1A. and it's 1b. So please use all these mathematical symbols and stuff. Obviously, teachers that are marking your AP calculus exam, they used to these types of notations and stuff. And they also use these notations in the AP calculus. I mean, in the Stewart calculus, that's prescribed textbook. So it's fine if you use all these notations, right? It's an approved mathematical notation. So let's look at the next one. What does it say? Verify that G of Z takes the value 2 somewhere in the interval. So easy. They gave us the interval already. There's nothing to think about. It's a no-brainer. So you're going to substitute 0 inside here. So the first part, you're going to say G of 0. What is G of 0? E to the power 0 minus 4 cos 0. E to the power 0 is 1, right? Minus 4, which is equals to -3, isn't it? That's easy. We're trying to find the answer. And -3 is already less than 0, right? That's great. And if I find G of pi, I'm going to say that's e to the power pi minus 4 cos pi. Cos of pi, if you remember the cos graph, is -1, right? Cos graph
Yeah, Mr. It's -1.
is -1 times -4, so +4.
Mhm.
You can
Plus
clearly
4.
see that this answer is already positive, right? We don't care what the decimal value is, as long as we know that it is positive. So they exist a root x is equal to c. So you're saying c is a root, but c value is in the interval 0 to pi. Don't put square brackets now because we know it can't be 0, it can't be pi. 0 to pi, right? Such that f of c, in other words, why are you saying it's a root? Because if I take this root and substitute it inside, I will get 0. That's it. So you're going to say by the intermediate value theorem, by the intermediate value theorem. You need to state what type of theorem you are using. By the intermediate value theorem, there exists a root x is equal to c, which is where the value of c is. C is between 0 to pi, such that f of c is equal to 0. Are we good? So all we are saying that the
Mr. What
value.
about the 2? What's like this 2 in the question?
Yes, that's a nice question. Verify that it takes a value 2 somewhere in the interval. So isn't 2 is between 0 to pi?
0 to pi, yes.
Yeah, so let's
Okay.
try to
Uh-huh.
so we can say c, the value for c is between 0 to pi. The value of c, the value for c is between 0 to pi, and the value 2 is somewhere around here. Okay, so 2 can be an answer for c, but we didn't check that. So let's check g of 2. So you're going to say e squared minus 4 cos 2. Please put your calculator on radians measure and get me this answer.
It's 2 radians, Mr.
Mister, I don't understand.
What you mean? You don't understand? You don't understand what?
Mister, why? So, okay, so it's
It's
saying he wants the
9.05.
value of 2. So you substituted 2 inside the interval.
No, I'm saying 2 could be a possible
Yeah, I
solution
know, I
between the
know.
interval. Yeah.
So you found g of 0 and g of pi, right? To get
Yeah, that's
the
correct.
interval.
Yeah.
And
Yeah.
then
We're saying we are saying that the answer for c lies between 0 and pi.
so you obtain the derivative and then you substituted 2 inside.
No, I didn't
Why do we get
find
derivative?
derivative.
No.
Yeah, I didn't talk about derivatives here.
Yeah.
We are not doing derivatives. We are doing intermediate value theorem. We're just substituting values in the interval and saying one positive, one negative, and checking.
So
Yeah,
all you did was substitute 2 instead of x.
Yeah, substitute 2 in the place of x. That's
Mr. I got
correct.
9.05.
Oh, okay, so we're getting an
Yeah,
answer
that's the
of
correct answer.
Another positive one, yeah.
yeah, so we're getting another positive answer. But what we're saying is 2 is an element from 0 to pi. That's what we're saying.
Okay, that's essentially okay.
That's the whole idea of 2. What he's saying, verify that this here takes the value to some. Obviously, this is so easy, so stupid, because what they're saying, pi value is 3,14. Obviously, the value of 2 is somewhere in the interval 0 to
Yeah.
pi. So this shouldn't even be the question. Verify that there is a root somewhere in the interval 0 to pi.
Mm. Which would be
Verify
this
that
answer, right?
there is no
There
answer.
exists a root x equals c,
Yeah,
element of
yeah,
0 to pi. Okay.
yeah. The answer is just between 0 to pi. We don't know where the actual answer is
Yeah.
because we
Okay.
are not solving for the actual answer. If you're going to solve for the actual answer, that requires Newton's method, which the
Okay.
calculus BC guys do. But why does this help us? Because look at my function now. If you observe, my function is e to the power x. Let's take any value between 0 to pi. Let me take 1. E to the power 1 minus 4 cos 1. I need to put my calculator on radius mode. It is. See what my answer is. So I think I need to reduce more because this gives us an indication that the answer is squeezed between 0 and pi. Whoa, wait a minute. We got 9.05. So even better because now you can say, because the 2 was given, we can say that the answer is between 0 and 2. The value of c is even better because it's between 0 and 2. So now you can say they exist, x is equal to c, such that there exists a c with a value for c. You shorten the interval because of the 2, which is element from 0 to 2, such that f of c is equal to 0. So you now minimize the interval. Instead of 0 to pi, now you made it 0 to 2. You get it? That's the whole idea of the 2 there. Do you understand? Before it was 0
Makes
to
sense.
pi, but now because we substituted 2 inside, we also got a positive answer. So we rather take this. What's the idea of intermediate value theorem? To squeeze the answer in the shortest interval.
Okay.
So I squeeze the answer now between 0 and 2. So now what I'm saying is that there is an answer between 0 and 2. So that's why I chose a value of 1. So I chose 1, wasn't working out to 0, maybe 0.6. Let's try 0.6. I have to try different values, 0.6.
Wait, but
Okay,
Mister, in this case, why aren't we including both of the answers?
no, this is the
Because
final
both
answer
of
there.
them, so like g of 0 gives us a negative, and then g of 2 also, it gives us a positive. So why aren't we including them in the interval?
That's what I did. I included 0 to 2 such that
No,
f of
but
c
it's
is equal.
a round bracket.
But 2 does not give us 0.
Oh,
If
we're
you're
looking
gonna,
for 0. Okay, okay. F of
yeah,
okay, there we go. Okay, yeah.
I'm trying to get the actual answer for you here now. Let me substitute
Mm,
0.9. I substituted 1, nothing's happening. I'm checking where's the answer. So the answer, see, I got negative
very close to
0.026,
1.
very
Mm,
close to 1. Let me try 9.2. That's what you got to do now. It's trial and error
mm.
now. 0.086.
A bit far off.
No, it's not. No, no, no.
0.905.
The other one, maybe 991.
91
Yeah, maybe
or
91 will do.
905, something like that.
Yeah. So yeah, I'm kind of getting 905. You're right.
Mm. So can we shorten it even more and say it's
Yeah,
an
you can.
element of 0.91 to 0.92, you said?
Perfect. Yeah,
Okay.
perfect.
So
That's
we
the
get
whole
it as
idea of
close to
intermediate
the
value
middle
theorem.
point as
Yeah,
possible.
yeah.
Okay.
That's the whole idea of intermediate value theorem. Exactly. All right. So
Just
that
to
was
find
nice.
one answer, right?
Yeah,
Where f of c equals 0. Okay.
yeah. Remember, not necessarily one answer. You can have multiple answers because
Yeah,
the
of
graph,
course. If it's a
the
quadratic or if it's in this case
yeah,
an exponential or
like
something.
if there's a point here and there's a point there, it doesn't mean it's just a straight line. As I told you, you can
Mm-hmm.
go up and then come back down and then turn again.
Mm-hmm.
So now you got 3 routes in
Three
between the
answers.
interval. So it depends. That's why you keep on shortening the interval. So you just manage to get one answer in between the interval.
Okay.
Mesa, you understand? All right,
Kind of.
guys. Yeah, let's move on to Rolle's theorem. Now, Rolle's theorem is where we are doing derivatives, all right? So I'm going to explain Rolle's theorem here. Right, so what Rolle's theorem talks about is just a horizontal tangent. That's it. Okay. What's Rolle's theorem about? Horizontal tangents. Horizontal tangents. Okay. Now, that's the what's horizontal tangents? It means they are turning points, loosely speaking, right? They're turning points in between the interval. So what's the setup like? If this point is A, then this point over here is f of A, okay? And this point is B, then this point is B and f of B. So what this here says, what Rolle's theorem says, is that if you have f of A is equal to f of B, obviously there are conditions. If you have f of A is equal to f of B, in other words, f of A value and f of B values are the same. It means it has the same y value, okay? Now, if you're trying to connect f of A and f of B, obviously you can connect first with a straight line. It's already a horizontal tangent. Or you can draw a graph like this, continuous, get a horizontal tangent above, or you can draw a graph at the bottom, okay? So there are many types of graphs that you can draw. You can even draw a graph at the bottom like this, and you get a horizontal tangent here. Okay, so let me take that out. So what are the conditions? So what does horizontal tangent means? What Rolle's theorem says is that there's a value between, there's a C value in between A and B such that f prime C is equal to 0. What it says? F prime C is equal to 0. What's the slope at C? Isn't horizontal tangent means the turning point? What's the slope at the horizontal tangent here? The slope is 0. So that's what it says. So let's write down the conditions. There are three conditions for the Rolle's theorem. F of
Mister,
x, yeah, f of x is
isn't this
continuous.
just the same thing as a point of inflection?
No, I'm talking about horizontal tangents. Is this f prime x?
Oh, yes, yes, okay, okay, okay. My bad, my bad.
F of x is continuous on the interval. You know, must have an interval. It's continuous on the interval where? A to B. It must be continuous. You must also be able to differentiate. F of x is differentiable
So these
on,
are the conditions to apply
yeah.
Rolle's theorem, right?
Yeah,
Okay.
but we don't even use the first two because we can clearly see there's, as long as there's the function is not discontinuous, like there's no removable discontinuity, there's no jump discontinuity, there's no asymptote discontinuity.
Yeah.
The first two always holds. So f of x is differentiable on the interval is a to b. A to B. See over here, f of x is continuous on the closed interval. Why closed interval? Because this interval is closed. So sometimes they try to be technical on the closed interval, right? So these are like actual, this thing, on the open interval. Differentiable, it has to be differentiable on the open interval, okay? So wait, I went and moved this and now f of x. Differentiable on the closed interval, on the open interval. And the third one is they exist C, which is in A to B, such that f prime C is equal to 0. Let's see if they wrote it out like that. So do you have this? So then there is a number, oh, there's a third condition, f of A equals f of B. I was talking about it and I didn't write it. Okay. The third condition is the two y values are the same at A and B. So f of A must be equal to f of B. So there exists a C in A comma B such that there is definitely has to be a horizontal tangent. It doesn't matter how you connect. You can connect using infinite paths, even if you connect like this, or if you connect like this, right? There's so many ways to connect the two dots. The shortest way is a straight line. And if you join a straight line, it's still a horizontal tangent. If you join, so it needs to be between the interval A and B. So it should be on the open interval, yeah, A and B. Such that f prime c is equal to 0. No. Why do I keep on making a mistake? I had it right first. It's supposed to be open interval. Because obviously this is a condition, so it can't be on the endpoints. Yeah. Are we good, guys? Why is
Yep.
the interval open? Because we're finding the derivative, and derivative got to deal with differentiable. So it has to be open interval. Right? Now, let's solve a question so you can understand this scenario. I do have a question here, which I made up, right? So I have this function here. I've got x squared minus 2x plus 3. So this is 2a, the second problem, right? Number 2, because we're doing Rolle's theorem, which is 2. I've got 2a, and I'm going to put an interval here. X is an element from 0 to 2. Okay? Now, let's observe. Let's apply Rolle's theorem here. Here's my question. I sketched this graph for you as well, right? So you must know how to sketch graphs. It's a quadratic function, basic stuff, right? Oh, by the way, how can I sketch this function? We can put it in TP form. Isn't we can put this in the TP form. So y is equal to x squared minus 2x plus something squared minus something squared plus 3. What we notice that something is negative 2 divided by 2, so negative 1, negative 1. We see that we have x minus 1 all squared, minus 1 plus 3 is plus 2. So obviously this equation has a turning point at 1 and 2, and if the graph is opening upwards, it can't have x-intercepts, okay? Because this part is always positive. It's always greater than 0. So that's the reason why the graph looks like this. Okay, so the turning point is at y 1, 1. X squared minus 2x plus 3, x squared. Yeah, it shouldn't be 1, 1. 1 second. Let me redraw this graph on Desmos. X squared minus 2x plus 3. Yeah, and just take that piece of the function, all right? X squared, x squared minus 2x plus 3. Okay, we see that. Yeah, so we're only interested in this piece of the graph because they said must sketch the graph between 0 to 2, okay? Now, I want you to look at the interval. So here's my solution, f, right? We can see that the first two conditions hold. We say f is continuous on 0 to 2. We can see the function is continuous from 0 to 2. You only have this piece of the graph you need to focus on. Don't worry about the rest. F is differentiable. What does differentiable mean? You can differentiate, you can get instantaneous gradients, instantaneous slopes along that line. Differentiable on 0 to 2. And the third condition is f of 0 is equal to f of 2. Isn't f of 0 and f of 2 are both equal? What is f of 0? 3. What is f of 2? 3. Both of them gives us the same value. So you can say they exist a C. They exist a number C, right? They exist a number C in the interval A to B. Remember, there exists a horizontal tangent here between, so because if you join from 0 to 2, you can join this line here but that's not a horizontal tangent. So the horizontal tangent depends on the type of function you have. So there's a horizontal tangent here. So this is the value of C. So now over here, you're going to say f prime C is equal to 0. So there exists a number C in 0 to 2 such that f of C is equal to 0, f prime C. Now let's find f prime C. What is f prime x? F prime x is from the original function 2x minus 2 is equal to 0. So x is equal to 1, okay? So which implies the value of C is equal to 1. Is the number C between 0 to 2? And is, so we check, this is just a check, okay? We're checking. So C is between 0 and 2. So this condition is checked. And we're checking that is f prime C equal to 0? Is f prime 1? Is it equal to 0? Yes. This here implies horizontal tangent. Guys, you understanding? So what are you doing? What are you doing in the Rolle's theorem? You have an interval for a function and you're checking if there is a turning point between two intervals. Are we good? So what are the two intervals? 0
So
to
the only
2.
thing I don't understand in this question is why did you do perfect square in the beginning? Complete the square.
TP form, turning point form, vertex form. This is a standard
Okay.
form of the equation. This is a vertex form of the equation. What's the vertex from here?
To
1
get the
and 2.
vertex form, you don't need to write it in TP form. Just calculate the vertex and then substitute it back in and then write it as vertex form.
Good. That's another method.
Can I do that?
Of course you can.
Like
That's
minus
it.
b over 2a and then I substitute it back in to get y.
Yeah. You can do that as well.
Okay.
So that's my
But
graph.
why did you do vertex form?
Because I wanted to check if there's x-intercepts of this equation. I can clearly see there's no x-intercept. The graph is positive, and once I get the vertex, I will know whether this function has an x-intercept or not.
But on the vertex, it changes from a minus to plus. So the vertex should be the answer.
1 second. What do you mean it changes from minus to
You
plus?
said Rolle's theorem. You look at you like evaluate for example, you want here to see if there's any turning point between
0
from
to 2.
0
2.
0 to 2. Yes, at 1 it
Why
changes
at 1?
from
No,
negative to
I never
plus.
talk about changing slopes. I just said you have 0, f of 0 is 3, and f of 2 is also 3. So that condition is satisfied. F of 0 equals f of 2, which is equal to 3. So what I said was, for this function, if you draw this function, there's a horizontal tangent in between 0 and 2. That's all I
Yes.
said. I didn't talk about gradients changing and increase and decrease, nothing. I just
So
said,
what about
is there
what about f of 1?
f of 1
Something
is
happens
0.
at f of
F of
1.
1 is 0. That's where the horizontal tangent is. I'm proving to you that the value for C is a critical value. C is a critical value of this function. And the critical value of this function is between 0 to 2.
Wait, Mr. F of 1 is like
0?
minus. No.
No. F of 1
F of
is a
1 is 2. F prime 1 is 0. Yeah,
yeah,
F prime 1.
not f
Okay,
of
okay,
1,
okay.
not f of 1.
My
F
bad, my
prime
bad.
1.
Yes.
The slope at
The
1,
slope is,
the slope
yeah,
at
slope
that
at 1 is
instant is
0.
0.
So
Yeah.
basically f of 1 is 2 and then the derivative of it is 0.
Why are you finding f of 1? What's the point of finding f of 1? Tell me.
Because you said between Rolle's theorem, you have to look for, you said it, what is the definition of it? You look for a point that satisfies the solution between 0 and 2.
No. I didn't say that. I said for Rolle's theorem, it must satisfy the condition that when you substitute the endpoints like 0 and 2, both the values must be the same. F of 0 is 3, f of 2 is 3. Since both the values are 3, you can draw multiple parts of the graph, but you can't because you already have the function. The function is quadratic, so it dips and then goes up. Where the place where it dips and goes up, that's where the
So
horizontal
basically f
tangent
of
is.
1, we ignore it.
Yeah, we need to say f prime 1 is equal to 0. Because the horizontal tangent is at x is equal to 1. X is equal to 1 is where the horizontal tangent is. Okay, let's take another example
Okay,
and
okay,
understand it
okay.
better. So what was intermediate value theorem finding? Roots between two intervals. What is Rolle's theorem finding for you? The horizontal tangent between the two intervals. Make sense?
Yes.
Yeah, don't confuse that, please. Now,
Just a quick question.
yeah,
During the AP exam, will they give us a formula sheet or no?
there is a formula sheet.
Okay, good.
Wallahi, there isn't.
There's no formula sheet.
Wallahi, there isn't.
No,
They
man,
don't. No.
there
No
should.
way.
Wallah,
You
there's no
sure there's
formula
no?
sheet,
One
bro.
sec.
Oh no,
AP.
you know why? You know why there's no formula sheet?
I
Because
did the
this.
exam last year, but they told us there is and there wasn't.
Oh man. Then you gotta remember all the rules. But
Oh God.
integrals, there's not
No,
so much
mister,
of
but like
rules.
the formula sheet that like they gave us something, but it was like, you know how like in the SAT they give you basic stuff, like for example, they tell you the meaning of like a point of inflection, they tell you the meaning of critical points, but like they don't tell you, for example, the derivative of sine x is negative cosine x. You need to memorize
Yeah,
stuff
you
like
need.
that.
Yeah, you need to know the basics. That's basics, man. Come on. Okay,
Azadi,
guys,
see what I sent you.
I will check it up later. Let me finish my lesson first. Okay, guys, this is great. Let me look at the second question here. Mm, okay, this is like kind of typed out. Okay, should have just cropped it out. Second. All right, so I have a second question on Rolle's theorem. Let's see if we can solve this. It's on Rolle's theorem, right? I even sketched the function here for you, so you can make sense of it. So I'll call this example B. I gave multiple choice here, right? So check. The function f of x is equal to x squared minus 6x plus 10 satisfies the hypothesis of the Rolle's theorem. So it satisfies the hypothesis of the Rolle's theorem on the interval 1 to 7. They even tell you it satisfies from 1 to 7. Let's just find f of 1 and check. F of 1 is equal to, see that point, 5. And it's also equals to f of 7. I don't even have 7 here. Okay, 1 to 7. So, but it's 1 to 5 is equal to f of 5. So it shouldn't be from 1 to 7. It should be 1 to 5. It satisfies the Rolle's theorem from 1 to 5. So we know that f of 1, the value is 5, and f of 5, the value is also 5. So from 1 to 5, not 1 to 7, sorry. Right? Because if you substitute 7 in the function, you're going to get a very high value. So that is equal to f of 1, both the values are 5. It satisfies the third condition. So there exists a number C in the interval 1 to 5 such that f prime c is equal to 0. And you can clearly see that the value is between 1 and 5, and that value is 3. That's where the horizontal tangent is. So you can go and find the horizontal tangent. Note, to find the horizontal tangent, you're going to say f prime x is equal to 2x minus 6, the derivative, all right, which is equal to 0. So x is equal to 3, which implies c is equal to 3. We can clearly see that c is in the interval 1 and 5. Makes sense? So we're just proving it. We don't need to do all this extra. It's not part of Rolle's theorem. Rolle's theorem just stops there. They say the f prime c is equal to 0. So you have an indication of where the turning point is, where the horizontal tangent is. The horizontal tangent is definitely between 1 and 5. It can be 2, it can be 4. We don't need to solve it. Same like intermediate value theorem. You don't need to solve where the root is. Okay. We just need to state where the answer is for intermediate value theorem. For Rolle's theorem, you just need to state where the horizontal tangent is between the interval 1 and 5. Okay. And I proved it to you that the horizontal tangent is 3, which is between 1 and 5. No need to do this. This is extra work. Same like for intermediate value theorem, we're substituting values, we're trying to squeeze in values over here, right? And we had 0. I don't know, 0.91, and no need to do that. The intermediate value theorem is just an indication of where the answer is. Rolle's theorem is just an indication of where the turning point is, or where the horizontal tangent is. Let's go to the last one, mean value theorem. Are we good, guys? Hello? You understanding?
Yep, makes sense, mister.
Right, excellent. Right, so let's take one theorem at a time. No need to rush through everything. Now we are looking at mean value theorem. So what's the setup of the mean value theorem is something like this. And we have some questions here as well, right? So in the mean value theorem, what the mean value theorem says is no more, so now it's not f of a equals f of b in the mean value theorem. The condition is the first two is the same as the Rolle's theorem. F is continuous, is continuous on f of x is continuous on a to b. 2, f of x is differentiable on a to b. Differentiable is always an open interval. And the third one is, so let's see what the third one is. You see, you've got a here, right? And you've got b here. You see this, you see the slope, see what they're saying over here is that you've got a here, you got b there, then there's a point C in between A and B such that the slopes are basically there's a
So they're
horizontal.
parallel.
Yeah, they're basically parallel. So
So
what you're saying
f
is
of
that the
b
average
over f
gradient,
of a is equal to f of c.
f of B, no, the gradient,
No?
the gradient of
The
A,
Mister,
gradient.
the
the
mean
gradient.
value
Okay.
theorem, is it where f of b minus f of a
Or f
over
of b
b
minus f
minus
of a.
a?
Yes, 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 yes.
Yeah. Mean value theorem is
Okay.
average gradient is equal to f prime C, the instantaneous gradient, where the instantaneous gradient is equal to the average gradient. So what's the average gradient? F of B minus F of A. Average gradient is just a slope. So it's F of B minus F of A over B minus A is equal to F prime C. Now where's the value of C? C is in between. There's one more condition where the value of C is in between A and B. Okay. So that's a condition. I just want to check the actual formal definition for the mean value theorem. So we're going to consult our textbook, which is the calculus. Mean value theorem is, then there is a number C. So we stated that then there is a number C, A, B, such that, or equivalently, we don't need to use the second equation. Let's just stick with the first one. F of B minus F of A over B minus A. That's it. Are we good, guys? So let's take an example now. So what does the mean, what's the purpose of the mean value theorem? The mean value theorem says, okay, I have a point A and I have a point B. So what he's saying is they're not talking about the horizontal tangents now. They're talking about, okay, if I join point A and point B, there's many ways to join that point. If I join point A and point B with a straight line, there will be another line which will be touching the graph in between A and B such that these lines will become parallel. So the instantaneous gradient is equal to the average gradient. Okay. What is this? F prime C is that is the slope at C. Slope at x is equal to C. In other words, it is the instantaneous gradient. Instantaneous is a instantaneous slope. Slope at that instant. Instantaneous slope. Okay. And what is the average gradient? Is, it's like That's how like average speed cameras work, you know, between two time points, right? Just say you were going very fast there, and over here you slowed down because of average speed. So that's your average speed, right? But in between that, you were doing some maximum, you were doing something that is close to the average gradient. You get it? So that's how average speed cameras are like, that's how they track you down on, and they give you a fine on average speed cameras. Anyways, let's have a look at an example based on this. So I'm going to paste it here. Look at this question. The function 3x squared plus 7x plus 3 satisfies the hypothesis of the mean value theorem. So they're telling you it satisfies the hypothesis of the mean value theorem. It means that it satisfies the first two hypotheses on the interval 5 to 9, right? Find the values of C that satisfy the conclusion of the mean value theorem. What's the conclusion of the mean value theorem? So we're going to substitute 9 inside. If I substitute 9 in this function, what do I get? Someone please work it out. 3 times 81 plus
309.
7 times 9.
309 Ghazali.
Checking out 309. And what is f of 5?
F of 5 is
Just give it the
113.
113. And what is okay, so let's work out what's the average gradient here. Average gradient is 309 minus 113.
Yeah,
F of b
309 minus 113 over 9
9
minus
minus
5.
so 9
49.
the answer is 49 here. Now on this side, I'm going to work out what is, wait 1 second, let's write it out properly. Right, so let's put and, right, and now on this side, you're going to work out the derivative. What is f prime x? F prime x is 6x
6x plus 7.
plus 7. So what's f prime c? 6c plus 7. Just change the variable from x to c. So now make
And then
this
I
average,
substitute.
make this average gradient is equal to 6c. Remember this answer was 49. So
Here
the,
you would get f of 9 for the derivative is 61.
what are you saying? No, there's no need to substitute here. There's no need to substitute here. We're solving for c. Find the values of c that satisfy the conclusion of the mean value theorem. Remember,
So
the
6c plus 7 equals 49.
yeah, so 6c plus
Oh.
7. Average gradient is 49, and this is 6c plus 7. So negative 6c is equal to 7 minus 49. That's negative 42, right? So c is equal to 7.
So why did you obtain the derivative?
You have to find the derivative because the slope, what does the slope represent? F prime x. The slope has to be equal to the average gradient. See the slope. These two lines are parallel. So parallel lines have equal gradients.
Oh,
Yeah, so average gradient must be equal to the instantaneous gradient at C, and the value of
Mister,
C
is
is
it talking
between.
about this graph above because it's a negative slope, or is
No,
it
no, no, no,
just
no, no, no,
the
no, no,
graph
no.
isn't
It's
given,
general.
right?
No, the
Okay.
graph is not given. It's a
Okay,
new
okay.
graph. Remember the value of C. We're saying there exists a number C, which is between 5 and 9.
5 and 9. Okay. So, Mister, if we
Such
connect the
that
points on 5 and 9, if we connect those 2 points, that line is going to be a slope of 7, right?
that line is going to give us a slope of 49. If you connect the dot 5 and 9 on this graph.
Okay.
Okay, let me draw the graph and show you, right? Let's draw the graph. We were supposed to be stating this because they said that satisfies the mean value theorem. So that statement should be going first there, right? There exists a number C in 5 and 9. Right, so I'm going to draw this graph here for you. 3x squared plus 7x plus 3 Desmos. It was 3x squared plus 7x plus, see now, I forgot the function. 3x squared plus 7x plus 3. That's my function here. And the value was between 5 and 9. Whoa, those values are so big. Okay. No, that value is like, those values are like really big. And that's the reason why the slope is 49. You can see how it's going. Can't even stretch this graph. Okay, anyways, let me go and draw this graph in a different way, like 3x squared plus 7x plus 3. 3x squared plus 7x plus 3. I have a problem with drawing this graph because it was between, the points were between 5 and 9. And 5 and 9 is like way around here. That's why the y values are too big. But you can see that the slope is positive. So what we are saying here, let me draw it by general theory, right? What we are saying over here is that, that's a good question, right? So for understanding purposes, it's important, like, we know this function is already sloping upwards, right? And 5 and 9, the value of 5 is giving me 113. And the value of 9 is giving me a point which is higher up. But remember, this is a quadratic function. Value of that is giving me 309. So I have, okay, I have a graph like that. Not necessarily so much of curve, but it's fine. Just say if the graph is curving upward because it's a quadratic function. Now, what I'm saying here is that if I join the coordinates A and B, right? So this point A and B has slope 49. You get it? So the slope between A and B, the average gradient between A and B is 49. Which is also equals to the second line, which occurs at 7. That point there. And those two lines are parallel.
Okay, I see.
You
Yeah, yeah, okay.
understand?
Yeah.
Ah.
Oh,
So that's
okay.
what we are saying. So the value of C is between 5 and 9. That's here. It's just that because when I sketch on Desmos, you can see it's sketching an actual accurate graph. So now I've kind of like broke up this interval to show you that that's what's happening. And that's where 7 is. That's where the instantaneous gradient is, and that is the average gradient. So the answer there was 7. We can take one more example before we end off, right, on the mean value theorem. We have a nice question over here. Look at this question with E and stuff, right? So those are the 3 important theorems that you need to know. That's it. So mean value theorem, this is my second question. So 3B, because this is the theorem which is third theorem. Nice, guys. All right, so determine the numbers C which satisfy the conclusion of the mean value theorem. So what we need to do here, we want to find the value of C, all right? So first we're going to substitute -2 inside this interval, then 3 inside this interval, get the average gradient. So what is A of -2? A of -2 is 8 times -2 plus E -3 times -2. Can someone give us this answer? And I need
387.428.
387.
Around it, 0.4.
Such a big answer. How? Oh, yeah, because that's 2 to the power 6. 387 point. No. I want 4 decimal. We still have to round off more.
0.4287935.
879, so 88. Guys, I hope you are also using the calculator and getting these values. No, it's not only Mesa, right? What's A of
I'm
3?
using the TI, the Texas one.
So with the 3 now, you're going to substitute 8 times
24.
3.
24.
plus e to the power negative 3 times 3. Because when I substituted,
Yeah.
what are we getting?
24.
24 exact.
Yeah, Mr.
20
24.000123341.
0.000001.
Okay, we take it as 24, right?
Okay.
So what's the average gradient here between this interval? Oh, wait. Before you do this, because they say it's satisfied, you must say they exist a C. And we keep on forgetting that. They exist a number C, which is between -2 and 3.
How do you know?
Because they're saying it satisfies the conclusion of the mean value theorem.
So that means it is
It's
differentiable
between,
and it's continuous.
yeah, and is
Yeah.
between -2 and 3. You don't even need to remember all polynomial functions are differentiable and all exponential functions are differentiable and continuous. And all sine and cosine functions are continuous and differentiable. Tan is not continuous and differentiable because you know there's an asymptote. Right, so average gradient is 387.4288.
Wait, Mr. A number C is an element of that range such that what? Such that what function or what
Such
condition?
that average
prime.
gradient is no
Oh,
such
average
that
gradient.
average
Yes,
gradient
yes.
is equal to f prime c. That's a condition. That's what
Is
we're
equal
trying to
F
do
prime
here
C.
now.
Yeah.
Yeah. So on the left hand side, I'm doing average gradient stuff, and on the right hand side, I'm going to start doing derivatives.
Mister, you
That's-
get minus 72 here.
Wait, I need
Minus
to
72.685.
How are you getting negative? Because I'm taking 3 minus 2.
No.
No, it's wrong. All right, so 387.4288 is -2, -3.
3. Yeah.
Yeah, so what's the
Minus
answer?
72. Minus 72.68576. So
685.
0.688. 6857 Ghazali.
6857. Good. Now let's find f prime c. F prime c will be the derivative. So let's find f prime x and then change the x into a c. So that's 8. Anyone remembers how to differentiate the e function?
Product rule, right?
Where product rule came from? Product rule is product of two functions. This is two terms.
Ah.
What's the
Mr.
product?
Derivative of E is E.
E to the power
Then
negative
E to the power of
3t
-3t
times -3.
times -3. Yeah.
Derivative of the top. Good. So what is
Yes.
f prime c? Sorry, it's not f prime x here now. The variable is
Mr.
t
It's
here.
A prime T. Yeah, or F prime T.
It's even a here, even worse.
Yeah.
That's a. So the function is a prime. Okay, these are just minute mistakes. You want to find the value of c, all right? You can use any function you like. Doesn't have to be a of t. So let's see. A prime c is equal to, just for technicality, we change all the functions, all right? So we got 8 minus 3 e to the power -3t. Now don't write it out like that because remember you are solving an equation. So minus 3 over e to the power 3t.
3t.
Yeah, we change it around now. Now we need to equate both. Now average gradient is equal to 8 minus 3 over e to the power 3t. So wait, let me take out average gradient, which is negative 72.6857. This implies, right? Now we're going to solve this. Bring 3 e to the power 3t across and take that over. So add both. That's going to give me 80.6857. And this is 3 e to the power. Let me bring this back up, right? Negative 3t. So I can use len. You understand what I did here? I just took this whole entire term back to the other side and brought this over. 8 plus 72, that's 80. Take this back onto that side, bring the e to the power 3t back up, right? I want it in that form because I want to solve. So e to the power -3t is equal to 80.6857 divided by 3. What's the answer? 22, 23.
20.895.
Can never be because 20 times 3.
Yeah.
20 times 4 is 80. Come on, man. It's
Mr.
23 point.
80.6857 divided by 3.
Yeah. How can it be 20
Yeah.
point something?
No, no,
It's
no.
23.
Oh, my bad. 26.895. My bad.
26.895. 26.895. Right. Now, how do we solve this equation involving E? Use len. If you learn
Len.
both sides, you get negative 3t equals len 26.895.
Len
Then we're going to take that and divide
26.895.
by negative 3.
Okay, divide by 3.
Negative 3.
Divide by negative 3. Minus 1.0998.
Negative 1.098, which is approximately equal to negative 1.1. I think there was a multiple choice here. No, there was no multiple. So approximately negative 1.1. Is the value of negative 1.1 between -2 and 3? Yes, it is. Are we good, guys?
Yes.
Wait, mister, can you scroll down? How did you get negative 1.1?
We took len
Oh,
26.895
we
and
made a
then
negative
divided by
Solve
sign.
for
negative
T
3.
is 1.
Yeah. My bad.
Okay. All
No,
right.
I thought it was plus t. I put plus by accident. Divided by 3. Yeah, 1.0.
So approximately negative 1.1. And you can see the value of t is between, what did I put here? Yeah, the value of
It's
t,
between,
c
yeah.
-2 and 3. And why did I put t there? You
We're
guys
finished,
keep on.
Ghazali.
Wait. It's not t. We said a prime c. Where am I getting c from? There's c there. It's just technical errors here, okay? So go back and correct all the t's to c's. So this is a c. All right, this is a c as well. Because remember, we're finding a critical number, which is we're finding the instantaneous gradient, which is parallel to the average gradient, okay? There's no t here in the equation. It should be c. I even wrote it there and I didn't change it. Terrible. Right, so there's it here. -3 over e to the power 3c. That's why I'm checking where t came from. It's supposed to be c. We're finding the number c, which satisfies the conclusion of the mean value theorem. Right, guys, we're going to end off here now. I'm just going to stop the recording and then pick some
Yes, thank you,
questions. One
Ghazali.
second.